Sometimes in math, you run into this problem where a variable is just stuck. It's trapped somewhere our usual tools can't quite reach it. Well, today, we're going to learn about the one rule that can set it free, the Power Rule of Logarithms. Let's see how this thing works. Okay, so take a look at this equation right here. 2 to the power of x equals 3. How in the world would you solve for x? I mean, you can't just divide by 2, right? And taking a square root isn't going to help, so what's the move?
If you're scratching your head a little bit, that's totally normal. You've just hit the core of the problem. That x is just hanging out up there in the exponent, and, our usual algebraic tricks just can't get to it.
And this right here, this is a classic little challenge in math that we call the trapped variable problem. Without some way to get that variable down from the exponent, equations like this are pretty much impossible to solve. But lucky for us, we have a key.
And that key is the Power Rule of Logarithms. Seriously, think of it as the hero of our story. It's this special tool designed for exactly this kind of situation. It's what's going to let us finally free that trapped variable.
So what's the secret? What does this rule actually do? Well, it's actually pretty cool. The real magic of logarithms is their ability to turn these complicated powers into simple multipliers. It basically brings the complexity of an exponent down to the ground level, turning it into basic multiplication. And it can do this because, at their core, logarithms are exponents. Okay, so here's the official definition. The power rule says that the logarithm of a power is just the exponent times the logarithm of the base. If you look at the formula, see how the n starts out as an exponent on the x? After we apply the rule, bam! It's now just n times the log of x. It's no longer a power, it's just a coefficient. But honestly, the easiest way to remember this is with this little visual trick. Just imagine that the exponent, that little n, literally hops over the log and lands right out in front. It's a simple little mental picture, but it perfectly describes this super powerful transformation. All right, enough with the theory. The absolute best way to understand a math rule is to see it in action. So let's get our hands dirty and put this rule to work. Let's start with a really basic one. We've got log base 5 of x to the power 4. So what do? We just find that exponent, which is the 4, and we let it do its little hop right to the front. And just like that, it's expanded to 4 times log base 5 of x. Easy as that. Now, this works both ways, which is super useful. Let's try going in reverse and condense this expression. We just use the power rule backwards. We take the coefficients, the 3 and the 1/2, and move them back up as exponents. That gives us the natural log of x cubed plus the natural log of y to the 1/2. And since we know the 1/2 power is just a fancy way of writing a square root, we can then use the product rule to smush it all together into a single log. Okay, don't let this one scare you. It looks complicated, but it's just a combination of all the rules we already know. First step, rewrite that big square root as a 1/2 power. Now, we can use our power rule to bring that 1/2 all the way out front. Next, we look inside and use our other log rules to expand the fraction. And for the final step, we just distribute that 1/2 to each piece. See? We're just following one simple rule at a time. Okay, hang on a second. Before we go any further, I have to show you this. This is probably the #1 place where people get tripped up, so let's make sure we nail this down right now so you don't make the same mistake. Listen up. This is super important. Squaring the entire logarithm is completely different from taking the log of a number that is squared. The power rule only applies in that second case, when the exponent is inside the log attached to the argument. That's the only time it's allowed to hop out front. Please don't mix these two up. So you might be thinking, okay, that's a neat math trick, but what's it actually for? Well, get this. The power rule isn't just for your math homework. It's the key to solving some incredible real-world mysteries. Let's look at a really famous one. You've probably heard of carbon dating, right? How scientists figure out how old a dinosaur bone is. Well, this is the formula they use for radioactive decay. And would you look at that? See our little friend t for time? Yep, it's trapped way up there in the exponent. So how do they free it? It's actually amazing. They just take the natural logarithm of both sides. That single move allows them to unleash the power rule, which lets them grab that whole exponent, including our variable t, and bring it down to the main level. And just like that, the variable is free, and they can solve the equation for the age of the fossil. It's incredible, and it would be totally impossible without the power rule. And that leaves us with this final thought. We've seen how this one simple rule helps us unlock the secrets of ancient history. It really makes you wonder, doesn't it? What other huge scientific secrets, from how populations grow to how investments compound, are just sitting there, waiting for this one little rule to come along and unlock them?